Ventura. We've had a few conversations out in the edges of this conference, because the things that happen at the edges are sometimes as interesting as the things that happen in here. This is his first year here. He used to be a manager, 400-person department up at AT&T, and he went through the usual corporate ladder, and rungs broke off of it, and he found that he really wanted to make something different in his life. So from up there in Seattle, he had that revelation that a corporation is an entity that contains people, but as an entity can't feel pain or remorse. So it's sort of like having a little brother who's a criminal or something. Yeah, that's okay. Yeah, and from that insight, he decided that he would follow this anti-gravity thread. And so he has created www.americanantigravity.com. He's following the data where it takes him, and he's gathering and producing an intense amount of data on this subject. This was founded in 2002 because the time was right. People are getting more receptive to this information, and his total focus is on anti-gravity research. So here's Tim Ventura.
I can use that. I'll just use the hand mic. I don't know if the headpiece is available or not. Oh, okay. Should I turn this off then?
Yeah.
Okay. Awesome. Sorry, I've never been wired to a mic like this before. I've done lots in radio and TV, and that's pretty much just like anything else. You get used to it, and it's almost like the camera's not there. And in the case of radio, it's really just using a phone, right? Coast to Coast AM, Lou Gentili, Jeff Rentz. We do a lot of media, and our media work is really focused around helping to educate the public. Now, one of the things that I've noticed, I guess it comes down to key values, some key figures in this instance. Things like maybe 10, 15, 30. These are the number of seconds in a commercial. And these commercials are so ubiquitous in our lives that we're used to picking up bite-sized chunks of information. So I think as we're all members of the alternative science community, one of the things that we have to start looking at is how can we parcel out the information that we're providing to the public? How can we put this into a package that's acceptable to a soundbite culture? So one of the things that we'd like to start out with are some of the video clips that we've put up on AmericanAntiGravity.com. Now these grew out of, we started out with MPEG videos. We were putting up these 15, 30-second clips. And at first we would put these up and we had a pretty good response. But as time went on, I started to take a closer look at it and say, well, can we break these up? Can we make them more accessible to the public? And can we really drive change based on educating people through the kind of media culture they're used to seeing, right? They're used to commercials, used to TV, used to music videos. And so part of it has been trying to reformat this wonderful alternative science technology that we're all participating in into something that's hopefully somewhat slick. Now, I guess there's a caveat to this. One of our other approaches, one of the realizations, if you will, is that these technologies are raw. Now, I tend to think they're edgy also, but if nothing else, they're raw. Now, in the past, this has been kind of a detriment, right? We look at these things and say, how can we clean this up for TV? How can we show people, in the manner that they're accustomed to seeing how these things work? Well, fortunately, reality TV has provided us with the answer. With reality TV, the joke is if you kick the camera, it actually looks more real, right? It's all about the nitty-gritty raw details. And as it turns out, it's really hard to produce regular television that way, but with alternative science material, especially gravity research, free energy falls into this, alternative medicine, reality TV is really the order of the day because it's a mainstream art form, if you will, that lets us showcase some of these ideas in a very, I guess, nonlinear fashion. So if we could start out with some of the videos.
Young Raddy had just witnessed the world's first flying saucer, and this is how it was. which would draw air down into a curved shape like a saucer, which follows the surface of the
Turn me up a little bit.
by literally sucking the air from above the saucer so it flowed round and underneath. Coanda found he could both lower the air pressure above and raise it below, causing the craft to levitate. This became known as the Coanda effect, which is the principle of the path of
I
saucer.
said it. Hop, the hip, to the hip, hip, hop, and you don't stop. I rock on, baby, bubba to the boogie, the bang, the boogie to the boogie, the beat. And what you hear is not a test, I'm a rapping to the beat. It's me, the group, and my squad, we gon' try the beat. See, I am the Dr. Spot, and I like to say hello. I do the black to the white, the red and brown, the purple and yellow. But first, we gotta bang, bang, the boogie to the boogie, say up jump, the boogie, the bang, bang, boogie, let's rock. You don't stop. Rock the rhythm out of radio, body rock.
I think that's all of them, right? Okay. Well, so those are our video clips. I guess the thought on those that I would leave you with before I launch my PowerPoint is these technologies are where science ends, but they're also where science is born again. So we're really on that borderline between what we know is real and what's accepted and what we think may be the future. Now, I think one of the challenges that we have to really solve in the future as a community, again, is to be able to portray these technologies in a good light, in a compelling light that both captivates people as well as frames it in a context that makes it more palatable to some of the more mainstream types who otherwise wouldn't be interested in, I guess, what we call fringe technologies. So we have a lot of challenges as a community, but we've made a lot of progress. This is probably the world's shortest PowerPoint. Well, I think it's several pages long, but it only took me about an hour to put together. This is kind of our standard main page, I guess. This is the Lifter 4 prototype. Oh, sorry. Basically, this lifter measures 4 feet on each side, and I'll use a little laser pointer here. The way that we ended up measuring them, the word lifter, well, I guess I should start out with some background info. A lifter basically is a B-field-Brown effect, ion wind, quote-unquote anti-gravity device. They have far more cultural significance than they do actual usefulness. They are limited in efficiency, as NASA has, alluded to, I guess, in their many experiments. There are ways to make them more efficient. In 2003, we did a presentation for the Naval Research Lab outlining an ultraviolet pre-ionization process that would make these as efficient as an aircraft or helicopter or possibly even more. However, the mainstream view on B-field-Brown effect was that the issue was resolved decades ago, and they're just not interested. So, among other things, we've kind of kept these going, as well as begun researching new projects. Now, these lifters, I built this one in particular. The idea really came out of a company called Transdimensional Technologies They resurrected T.T. Brown's work in 2001. They actually resurrected it while they were doing testing on the B-Phil-Brown effect for Jonathan Campbell at NASA. So obviously this whole thing comes full circle. We found maybe a 10 to 20 year turnaround of the B-Phil-Brown effect. Basically every 10 to 20 years they come back to it and say, wow, this is great stuff. How come we never played with it before? And then they hit the first challenge, which is usually efficiency, and say, well, maybe that's why we didn't solve it in the first place. Using the laser pointer, so we measure them in the triangle. Now this is a compound lifter. So it's 4 feet on the outside edge. And we actually built this as a series of smaller triangles. In this case, if I remember right, it was something like, well, actually, you know, it's so integrated I can't even tell. But basically, we build them as a series of smaller lifters, glue them together, run a corona wire on the top. The quick version on the way this operates, there are two motive means of force, I guess. The first is ion wind. It's definitely there. It's obviously there. You can hear it. You know, it comes across in most of the films that we do also. The ion wind, we have a corona wire that runs across the very top. You can't see it. Runs up there. Now, this corona wire has a high voltage charge on it. Contrary to popular belief, it can be either positive or negative. Doesn't really matter. As long as that charge is the opposite of your ground. Now, your ground is your foil here. Now, this photo doesn't show it. Most photos don't show it. People get really lost and sometimes upset with us when they realize this. These devices have lots of connections. For instance, this one, and I'm not sure what corner it's at because it's not visible. This one should have a ground wire connecting from that going down to your common ground. The wire drapes. It's not suspended in any way. In fact, if it was suspended, it would short out. So it has to drape in free air. It has another wire going from the corona wire up at the top to your high voltage supply. Again, that has to drape. If it touches anything, it'll short out. We work in the 25 to 50,000 volt range typically, and at that voltage range, it'll ground out on just about anything, including concrete, right? Go right into the ground, the thing will short out. It also has tethers, tie-down tethers. One of the things that I found humorous when we started working with these in 2001 was people had said, you're holding this up with thread. Actually, we use sewing thread, and we don't use it to hold them up. We use it to hold them down. Because if you don't constrain how high these lifters are in the air, they will literally flip over the back of the power supply. Now, this particular shot that I did here, this lifter is probably about 10 feet in the air. So the height from the ground down here to this screen is probably the real operating height it was at, although obviously it's a little bit bigger up there than it is in real life. So you can take them up as far as you want. The caveat being you have to run power leads out to it. So the longer the wires, the more likely they are to get tangled, and then you have issues. But we do have tethers coming down from each of the three corners. Putting the tethers correctly on the ground, placing them correctly is a real pain, but we've managed to overcome that, I guess. So this thing has multiple connections going to it. Other than that, there is absolutely nothing at all above it. Now, one of the questions that people ask typically is, are the lifters pushing against the ground? The lifters aren't. You can tilt them. They will fly in whatever direction that they're pointed in. In fact, one of the ways that directional thrust was achieved by Naudin in 2001 was by powering different cells independently. He literally cut his lifter up into sections, and he had different ground wires for each section, and by reducing the voltage on any given particular section, he could make the lifter tilt, much like you would steer a helicopter. So they fly in whatever direction they're oriented, within reason. T.T. Brown, obviously, had a rotating disc experiment. In Brown's experiment, it was tilted on its side. That was why he was able to get it up to 12,000 RPM. It didn't start out that way. What it was really was a dynamic energy storage medium. Every time it spun, it added a little bit more energy to it, just like a flywheel. And eventually, it makes it up to 12,000 RPM, and the Navy classifies it. So this one doesn't come through well, I think, because we have the house lights on. But even so, this was smoke testing. I loved this photo. There's kind of light behind it. It's ego gratification to put it up, I guess. But one of the interesting things you can see in this photo, if you guys can see it a little bit, I'm at a bad angle. This lifter is actually orange. So this proves that the ion wind, or the ionic breeze, I guess, really does, to some degree, work. If you run a lifter in a very smoky environment, it will absorb whatever is in the air. And strangely enough, doesn't run any worse. In fact, they tend to run a little bit better if they have a rough surface. This lifter here, we actually use 4th of July fireworks. Light them off over the top and just run it, and the smoke will flow down through the middle. So the airflow from B-field brown is not linear like most people think. The first thing that you have is, actually, let me go back up to this. Well, let me flip slides. Oh, perfect. Okay, the airflow in a B-field brown device in a lifter, which is kind of the prototype for many of them. Again, your wire, corona wire on the top, high voltage, collector foil on the bottom. What happens is, we had thought for a long time that the airflow, the ion wind airflow that the government and everybody else has described in detail, was right from the wire to the foil. It would quite literally travel down from that wire to foil. Yeah, that was the popular conception. We thought, well, these things are flying because of airflow, right? It makes sense, very aerodynamic, you know. So I did an experiment where I cut the top off a lifter, cut the wire completely off it, just had the foil. Then we took the wire and suspended it literally on a stick and held the stick above it. The foil, with nothing connected to it, still flew. So what it showed us is, it's not a direct interaction. There is indeed air flowing directly between the wire and the foil. In fact, it's flowing at an incredibly high velocity, several thousand miles an hour. It's flowing fast enough that at higher voltages, above 50,000 volts, it creates a slipstream. There's absolutely no aerodynamic interaction. So the lifter is more efficient at the lower voltages. Now, the other thing it does is you end up with a space charge. This was kind of the magic behind the airflow. This is something we hadn't realized up front. This wire here emits ions all over the place in the air. It forms a cloud of ions. So this entire area, if this lifter was real size, you would have a cloud all the way around it. That foil is attracted to the entire cloud. So that is the reality of ion wind. And that's why it's so difficult to measure, and that's also why it's so difficult to isolate. These ions are literally everywhere. They're incredibly messy to work with, impossible to contain. People have asked about putting in solid dielectrics. Numerous people have tried it. The main problem with solid dielectric is you can take it up to a specific voltage, you invariably get breakdown. The ions will find a way around it or through it or some way to get from that collector, from that wire, the emitter wire, to your collector, your foil. So this is just a close-up shot, again, other than my demo, not that remarkable. So who here has not heard about American anti-gravity? The reason I mention that, let me, 2 or 3 hands. Okay, so maybe 5–10% of the audience at best. Let's start out with some of the basics, I guess. We do a lot of media work. We started out, again, the ego gratification, showcasing a lot of the stuff that I built, and over time, like anything else, it evolves. People started sending me their ideas. Now, at first, I'd thought, well, okay, why don't I put some of this stuff up? You know, this is wonderful research. And then over time, I started to realize people are sending us their dreams. This is their vision. This is their reality, the thing they tell their friends and coworkers about, and they can't get the time of day locally. They send this to us, and they ask us to really become caretakers for their dreams. So it kind of started to show us this community obligation that we had. And it's kind of evolved from pure anti-gravity into aerodynamic effects. We do some Coanda effect work, lots and lots and lots of Searle effect and related, because there are probably 40 or 50 different variations on the SEG. More recently, we've played with unified field theory, Heim theory, superconductors. There are probably 10 variations on superconductors, as well as the Nazi bell, which leads into the TR3B. So there's a lot of research. In fact, one of the reasons I decided not to focus on the research was I had found last year, in mid-last year, I did an interview with Jeff Rentz. And this was a 3.5-hour interview. At the end of that 3.5 hours, I realized that I had managed to go through my entire list of projects. Everything we'd covered on the website, all the really important stuff we've been able to do. So that was the middle of last year. Then we got involved with the STAVE conference. And then, by some mysterious reason, the military started showing up. And they had their own set of toys and their own set of ideas and their own set of, obviously, complaints about the way that we did things. So what I started to realize was the amount of information that we had with gravity research was building exponentially. It was as if by getting the word out there, it drew this stuff out of the woodwork. So it just grew and grew and grew and grew and grew. And the last time I did a radio interview, the Lou Gentili show, I was only able to cover maybe 5% of the stuff out there. So in a way, it almost does a disservice, because if I came out today and said, look, here are the best trends in gravity research, I wouldn't be able to cover it all. That's why we really put most of it up on the website. Now, this frame is actually out of sequence. That could be my fault. This is our new website. It is not yet complete. It works pretty darn well. As you can see, I actually snapped this photo the day before I left. Bill Alec just posted this story on the 25th, so this is a really recent snapshot. Lou Gentili Show, and of course, TeslaTech, as I promised Steve Ellswick for graciously inviting us out. So this is our new website. The reason we built it was web design is probably like any other process. The original one that you build works for a time, and then it expands, and then it just becomes kind of archaic. Our old blue one, which should be the next, oh, it's not. Oh, well, let me, oops. So did I turn it off? Oh, no. Oh, sorry about that. I'll forward down to the bottom. This was our original site. This is the classic American anti-gravity site. Again, it's evolution in action. We started this in 2002, as had been mentioned in the introduction. I used to work in the IT industry. I've been doing web design since '96. I've managed 400-person staff at AT&T, so I'm used to corporate America. I'm used to the meetings, the money, that kind of stuff. And when I got involved with this, it was the deep, dark day of dot-com depression layoffs. So I started out with a basic website, built this graphic my last day at AT&T, just to kind of thumb my nose at them. Also built this my last day there. Other than that, almost nothing on this website is the same. We just added bits and pieces. When people started sending us stuff, this breaking news section here, that had originally been just every time I built a new lifter, I'd put it up and say, hey guys, check this out, new lifter. It evolved over time into kind of a compilation of what we've been up to. The problem became we had a lot of stuff that we wanted people to be able to look at. Some of it is, I don't know, maybe pride-based. Some of it was just important. The one that strikes me right now is I interviewed Peter Diamandis a few months ago. Now, this should have rolled off to the bottom, a long time before this. And I kept it up there because I felt good about the interview. The other one, which I don't see up there, yeah, actually it's not up there at all. Oh, I moved it over here. Einstein's anti-gravity. This was a story that took us 3 months to do on the Philadelphia experiment. We did in-depth research into Nick Cook's Nazi bell. And we put this up. It had kind of a moderate impact, I think. Too technical for a lot of people to get enthralled with, but we were happy with it. So, some of these also roll off much more slowly. What we found was this website was too big. People loved it. We were getting 1.5 million visitors a year, but at the same time, of that 1.5 million, people were sending us questions like, where do I find stuff? So we went up to this one. This is our new one. Now, one of the differences, I won't keep you on websites all day long, but one of the differences with this site, when we bought the tool, as you can see, our gallery stuff changed. We're not able to put up pictures of each individual project. There's my picture. What it does is you add a new user for every type of article you post. So I created a video user. Paul March wanted to be a spaceman. He works at Lockheed, so I figured that was okay. For our corporate stuff, that's a picture of the World Trade Center, where I actually used to work in Seattle, to distinguish it from the other one. So at first I felt kind of strange about this, and then I realized this is your website. This is a community-based resource. That's what we've all evolved into. Now, I still do my own research. I still have tons of ideas. I still write most of the content here. But this website gives us a unique opportunity. It gives us the opportunity to give out logins to people who are doing unique, valuable, alternative science research and have them post material. So that really kind of signaled a change, I guess, in our approach. Our goal is really to try and keep things polished and presentable, as well as build this out. We added a research section. Again, this was one of the things that the military researchers really wanted. It's probably no surprise. The military is more disorganized than anybody on the planet, unless it comes to, like, I don't know, guns or anything, logistics, right? When it comes to research, they create stuff and they lose it on a day-to-day basis. They go to these STAFE conferences every year, STAFE is a wonderful conference. You have representatives from Boeing, Lockheed, Department of Defense, all sorts of different branches, Air Force. They all come together once every year, publish tons and tons of paper on gravity modification. They had to fight tooth and nail to get this accepted by the American Physics Society. And once they did, the caveats on it were insane. For instance, when they publish a paper through STAFE, the APA, I think it's the APA, APS, owns the copyright. So they can only send out 10 copies to close friends, otherwise they are violating a copyright on their own work. So one of our goals was to try and help these researchers out. We're adding the research section to be able to organize and categorize these papers. These things are cumulative. They build off each other, you know, and this research also ties into such a variety of different disciplines that we're trying to add search features and indexing to it so that when you log onto our website and have a question about how does mercury relate to gravity, mercury pops up over and over again. Or bismuth, right? Probably everybody's heard of the bismuth gravity connection. Everybody has an idea of why this might connect in. There are 30 or 40 different possibilities. What we're trying to do is add in search functionality so that if you look up bismuth, it'll bring up all the theories and why they might be right, and more importantly, why they might be related. I think one of our greatest achievements with American Anti-Gravity has been taking diverse information from diverse sources and cross-correlating it. I mean, one of the initial challenges that we had with the website was when we started in 2002, the mythology is a killer for gravity research. The mythology was the reason why the public doesn't take gravity research seriously. And I shouldn't even say the public, I should say the mainstream scientific establishment. We found that the general public had a better grasp on this stuff from day one than PhD scientists. In fact, PhD scientists would ask us questions like, what is anti-gravity? Well, anybody who's seen Star Trek, I like Battlestar Galactica, right? Any science fiction show made in the last 50 years, you know what anti-gravity is. It doesn't have to be fully explained. It's anything that's not an aircraft or a blimp, you know? So people have argued a lot of the finer points, especially when you get to the PhD level. But again, the public gets it. And so we're building off of that. So in terms of the website, we were trying to look at this mythology and say, how do we address this and do it in a classy way and do it in a way that doesn't undermine, again, the dreams that people have entrusted to us. And I think what we arrived at was this idea of, instead of ducking around the mythology, actually addressing it head on. One of the things that I'd noticed was I've talked to Mark Millis from NASA's BPP organization, the Breakthrough Propulsion, a couple of times. And he always highlighted this need to downplay, like they don't use the word anti-gravity. NASA will never use that. They hate that word. They're actually afraid of it. They don't like to use the word gravity modification or gravity control. And every time the word gets used and people actually figure out what it really means, they have to come up with another way to rename it to yet, confuse people again. The reason they do that is because of this mythology connection. It's the science fiction. And so in a weird way, we have 40, 50, 60 years worth of stories that tell us this is how it works, this is what it is, educating the public as to anti-gravity. And yet, on the flip side of that, those same stories ruin its credibility. So we figured that the long and the short of it, we figured we'd plow right on through the mythology, If you can't get around it, which Millis apparently wasn't able to, we figured we'd go straight through and start addressing these issues. The Searle effect is an excellent example. Probably everyone here has at least heard a reference to the Searle effect. It's turned into really a soap opera in alternative science. And John Searle has been doing his research since the 40s. But the Searle effect is an excellent case study in terms of the mythology and the reality of alternative science. And in his case, one of the things that makes it so excellent is the length of time. It fades out of our current reality into the mists of history. So it's like, how much of this is really real? How much of it are stories that have been repeated so many times they're not even close to what really happened? How much of it has been made up and then interjected into this mythos for Searle? Right? We see the same thing with UFOs. Over the last few years, we've started to see some of the same things for some of the superconductor research. T.T. Brown is obviously a comparable example. The biggest departure, I think, for B-Field Brown from the reality that we know and observe, or at least the historical reality that we know, was the B-2 bomber, right? That was something that Paul LaViolette came up with. I believe he was the first person. A lot of people have heard that the B-2 may have anti-gravity on it. I came to a little bit different conclusion personally. Now, I don't know for sure. I've never been on one. Actually, never seen one in flight. But the idea was that they were using the B-field-Brown effect to create an anti-gravity effect. Whatever the reality of that myth is, at the very least, it started out being speculative and just became more speculative from there. So what we've tried to do is address some of these mythological aspects of gravity research to try and cross-correlate things and say, if person A sees a side effect, right, like the Searle effect generator runs cold. Now, Searle, when he came up with this idea, this is the 1940s, 1950s, he apparently just said, well, it looks like this thing gets ice cold when it runs. In fact, in his case, he said it became superconducting because it became so cold, which indicates, you know, several hundred degrees below zero. Well, if Searle just pops up and says it becomes cold when it runs, we can't tell one way or the other. We don't know what to think of that. But we do know if we see somebody over here, for instance, Marcus Hollingshead from the Marcus device controversy. Marcus popped up in 2000, I believe this was late 2002. Marcus had never heard of Searle, had absolutely no reference to Searle whatsoever, never even heard the name of it. He was an indie inventor who wasn't even looking for gravity. What he was looking for was a way to model the magnetic fields of the Earth for some arcane reason. And one of the things he'd indicated was it ran cold. So now we have two separate cases. Those aren't the only two, obviously. We start to piece these things together, and we have a class of device. And the interesting thing that we found is the more we cross-correlate data, and again, incredibly diverse sources, these people know nothing about each other. They know nothing about each other's work. They're separated sometimes by decades. And yet we're finding they're all converging in on a core set of ideas. You know, in the case of the SEG, not only did it run cold, it used the hallmark of what we think of as, I guess, well, I like to call it true anti-gravity. B-field-Brown has been argued to death. In fact, we got tired of arguing it. True anti-gravity, it would be, you know, in the words of Searle, it doesn't just take off from the workbench, it takes the bench with it. The Searle effect generator, you know, obviously one of the examples that he has cited, again, no verifiable evidence for it, was that it took the bench with it when he connected it to the bench and powered it up under a full load. Marcus claimed the same thing. There are numerous claims of effects like this. What we're seeing are these nonlinear effects, and they come out of essentially rotating magnetic field devices. It's hard to be more specific than that because there are hundreds of variations. What we're finding is, even in devices that seem diverse enough that they don't even match, like the superconductor devices. You wouldn't think superconductors would have anything to do with mercury plasmas, which tie into the Nazi bell, or anything to do with the Searle effect generator. And when you get down to the electrical and the field-based level of these things, you start to see the relationships here actually become uncanny. They're so striking that it's amazing. And again, you have side effects described by a diverse source of people, you know, people who've never met each other, that match up so well, it's as if they're describing the same phenomena coming from different devices. Now, there are tons and tons of theories that explain why this might happen. One of my personal favorites, my pet theory for the last year, has been Einstein's unified field theory. One of the things that I liked about this theory was nonlinearity of effects. The effects form an exponential curve when you're working at smaller energy levels, right, like all modern electronics, pretty much anything made in the last 20 years, right, your cell phone, your radio, anything like that, you're working so far down on this curve you don't see any effects. These unified field theory effects, because it's an explanation for everything, they're always there, they're always present. But you just don't see them, you can't measure them. They, for all intents and purposes, don't exist. So you start to work your way up this curve, and you might see some strange side effects. There was a company that I had done a story on. I can't really disclose it at the conference, unfortunately. They had done some testing that blew out their power supplies. It created unshieldable EM effects. That's a classic unified field theory effect. It's actually a back EMF that comes out of your gravitational field. You're creating ripples in time-space, and they hadn't thought to look for it at the time, but those ripples create conventional induction in circuits. And since it's going through any kind of shielding you might have, blows out the power supply. So as you work your way up the scale from there, you start to get what looks like the onset of maybe Philadelphia experiment effects. Again, it's a strange story, but the more research I did into this, the more truth I found behind certain portions of it. I guess I could phrase it like that. My focus was on the tech, not on the story, not on Montauk or anything like that. You work your way even further up, you begin to see full-scale gravity shielding. It looks like large-scale, again, true anti-gravity. There's not a linear relationship between input power and output thrust. I guess the best way to explain that is like a helium balloon. The example I like to use is, well, it's a horrible example probably, but let's say you connect a helium balloon or a balloon to a tank of helium and dump it over the side of a ship. Well, that tank will sink all the way down to the bottom of the ocean, right? Just the weight of it will make it sink. So it gets down to the bottom of the ocean, it's sitting there, not causing any trouble, and some really big fish comes along and turns the screw so that it can begin to inflate the balloon. That balloon will rise back up to the surface of the ocean. Now, one of the big questions becomes, where does the energy come from? It's a lot of weight, it takes a lot of weight to get that up there. It's a metal tank, it might be 6 feet tall. The energy doesn't come from the tank itself, much like a helium balloon. There's no work being done there. Well, there is work being done, but not in another sense. So anyhow, the long and the short of it, without mixing myself up on stage, is that the work is actually being done by the water, if you dump it over a ship, or by the air in the case of a helium, like a dirigible. So the force exerted on it comes from our own gravitational field. So we have lift coming from gravity. There's no energy expenditure going on there. And I think that dovetails back into Einstein's view of gravity, which was that it was a warping of time and space and not a force per se. Again, this is one of many theories. A lot of people would get upset with me for saying that, but this is an idea I'm particularly fond of. It also explains why Searle can give his device a half spin and walk away from it, and it may be able to cart away a 100-pound weight or a 1,000-pound weight. Or Marcus, who last time I checked was claiming that he could lift thousands of pounds with very little appreciable input energy. So it's this nonlinear effect. The nice thing about this, what this tells us is we can use electrical systems that don't require enormous amounts of output to lift incredible amounts of weight. And the reason is that because we're not actually lifting the weight. What it turns into, actually I think the story is up there, it becomes a gravitational transistor. I think that's what these things are all telling us. They're telling us this energy is out there, maybe it's free energy, maybe it's in the background of time and space, maybe it's not free at all, maybe it's just something that's naturally occurring that we just kind of sort of can tap into, don't understand why it's happening. Maybe we're tapping into something completely new, but whatever the case may be, by modifying time-space with a small amount of energy, time-space itself does the work to lift these devices out. On a larger scale, this explains pretty much every flight characteristic of a UFO ever explained. One of the problems with even the Beefield-Brown explanation, Beefield-Brown does affect inertia. Savoir did an experiment in 2001 where, actually this is a hallmark experiment for Beefield-Brown. Even NASA has not been able to explain this one. He took a lifter with 6 sides. I guess I could forward back up to the top here. Or not. Well, in 2001, Savoir built a lifter with 6 sides and mounted it vertically on a gimbaling system. A gimbal is, basically just a device that lets the thing rotate. So he uses a kitchen fan that's about 3 feet away from this, turns the fan on, it's hitting the lifter at an angle, so the lifter begins to spin, right? It's just air pressure spinning it around in a circle. Well, he lets it get up to around 20 RPM, and that's pretty fast. It's moving at a good clip. He's managed to balance it so it's not bouncing all over the place. And then he turns the power on. And keeping in mind that he'd built the system so that the upward thrust didn't stop the bearings or anything. He'd suspended it with that in mind. The lifter, within a quarter of a turn, completely stops moving. So then he turns the power off, the lifter begins to spin again. Now, the obvious complaint about this experiment is it's airflow, right? This space charge that we're creating around the corona wire is just dragging enough air with it that the fan can't spin at all. So he figured he would beat the critics at their own game, put the entire thing in an enclosure and did the same thing with the same result. So lifters create their own inertial field, but at the same time, they're not doing the kind of inertial nullification that we see from pretty much any UFO report out there. Right? They can stop on a dime. They can do a right-angle turn going Mach 25, 30, whatever the claim may be. they accelerate at speeds that are almost like they're not entirely in our dimension. And the true anti-gravity, this nonlinear effect, be it unified field theory, Heim theory is another possibility. Maybe the theory hasn't been written yet. These effects occur in such a manner that the normal rules don't apply. And I think what they are leading us ultimately towards are probably warp drives, as strange as it sounds. I guess the short example of that would be Miguel Alcubierre, right? He's a British physicist, published a paper, I think this was 94. Alcubierre suggested that if you could use, I believe it was negative energy, within conventional relativity theory, you could bend time-space to allow a ship to travel within a light cone. So even though you can't go faster than the speed of light, in his view, you can still travel faster than the speed of light by bending space. He said the only problem is we need this negative mass or negative energy to do it. Since it doesn't exist, it's a thought experiment. And he kind of wrote it off as the Star Trek warp drive that'll never work. Well, the problem becomes to get this negative energy, negative mass, if you use the unified field theory in place of conventional relativity theory, which is in fact why Einstein wrote the thing in the first place, these I don't know what they call it, fanciful requirements go out the window, and you can begin to look at large-scale modifying of time and space, maybe even someday leading towards large-scale quantum tunneling. Right now they've been able to teleport quantum states across a lab. Because of the way the theory grew up and it was modeled, it's always been assumed that quantum mechanics would somehow prevent these large-scale effects from happening. Right? They talk about wave coherence and all sorts of quantum mechanics effects that only work in a small scale. It's possible that by being able to modify the time-space continuum using the nonlinear theories that we're working on today, maybe possibly brain theory, actually, as a good modern example, we could begin to move towards the really far-out stuff.
What theory was that?
Brain theory. String theory, brain theory. Derived originally Michio Kaku's, but there are a lot of people who have participated lately on it. It is picking up some of the slack. I guess Kaku originally, when he started working on this, he's described his passion for it as coming from Einstein's unified field theory. Again, I'm trying to skim, and I should apologize, because there's so much back information here. And I know it sounds like I have a lot of it memorized, but I miss bits and pieces, and I always have people come up to me later and say, this isn't how that worked. But it's close. So I'm trying to think of some of the big stories that we did. Right now, one of the biggest is that I personally thought was interesting. Eugene Podkletnov, or Evgeny Podkletnov, depending on how you pronounce it. He goes by Eugene if you're writing him from the States. He did the rotating superconductor that was in the press. It got him blacklisted from pretty much every Russian journal out there. Got him blacklisted in the US too. Because he was blacklisted, it took him about 8 years to have NASA replicate the test. They never did complete it. They kind of alluded to this in the press. They said, well, we tested this rotating superconductor and we had negative test results. I remember reading something about that. Well, their negative test result was when he told them to take it up to 5,000 RPM to see a 2 to 8% gravitational shielding effect, they took it up to 200 and because of quote-unquote political pressures, dropped it. So they never completed that test. The Boeing, I'm sure you guys have heard about the Boeing scandal, right? Boeing was into anti-gravity. It was making all sorts of headlines. They were not studying the rotating superconductor. Despite what the magazines printed, they had a bunch showing a jet with a rotating superconductor in it. What they were studying was his second experiment, which virtually no one has heard of, including, weirdly enough, most of the military guys. His second experiment was a force beam generator. Now, I interviewed him in 2004. I was doing a story on Ning Li, probably the world's most famous missing gravity specialist. And I was trying to track down where she was. He's the only person who's corresponded with her, so in my humbleness, I thought maybe I can do an ambush interview and trying to get him to tell me right in the middle of it. So I'm in the middle of the interview, and it turned out he was the one ambushing me because when I asked him about this experiment, I said, you were using a Marx generator, basically 2 megavolt, I think 10 megajoule or something like that. It's a lot of electricity, a lot of energy. He's pumping that through a superconductor. It's not rotating, it's a stable, static superconductor. He tried it with a coil and without, seems to work comparably with both. Now, the way he published the results, he said it moved a pendulum. He kind of alluded to the fact that maybe it was producing something like 20 pounds of force. That's kind of what it read like. So I asked him about this, and I said, you know, I'd heard 20 pounds of force. That's a lot. That is remarkable for a gravity beam, which isn't supposed to exist. And I then asked him, could he elaborate on it? He actually corrected me and said, 20 pounds, where'd you get that figure? And I thought, well, where did I get it? You know, maybe I made it up. So I said, well, okay, what are you getting? And jokingly, I said, okay, hundreds of pounds? He said, yes, more than that. So according to Ponklinoff, and I have it on tape, it's clear as a bell. I actually did a second follow-up interview to clarify. The claim now is that he's working in Russia, punching holes through brick and warping metal, like hitting it with a sledgehammer, using basically this Mars generator discharge onto a superconductor. Now, one of the wonderful things about this is Ponklinoff has been firmly planted in the alternative science community for decades. Well, not decades, probably 1 decade, last 10 years. He is a very, very friendly, gracious individual. He's very supportive of all the work that we are doing to try and bring our technologies forward. But he's also been trying to work to get back into kind of the good graces of some of these organizations. And one of the things that struck me about the STEVE conference was, without even having realized it, 4 or 5 of the papers they published in the last 2 years support his newest experiment. So I think some of these things that are coming together, again, this convergence of ideas is very profound. I actually was pretty sure that 2005 would be the year of the quote-unquote big breakthrough. Of course, the single biggest problem remains to be funding. One of our goals with American Anti-Gravity, and yeah, I didn't take much thought to come up with this. One of my goals was I wanted to become a funding source. I wanted to be able to collect nonprofit donations. We were hoping to do $2 million a year, right, from the Bill Gates of the world and the other, wealthy individuals out there. We thought, well, let's say we put $500,000 into this, into the website, into the company, building it up, adding reporters, being able to cover more information. Put the other $1.5 million into one project a year. Wouldn't it be worth it after 40 to 60 years of debate about the Searle effect generator to do $1 million, $2 million worth of experiments with it? And at the end of the day, put all those results up on the web and be able to say to the world, look, here it is. It either worked or it didn't. I think it's equally valuable in either case, because if it works, that's it. We've got the definitive proof that we need. It's expensive. It's too expensive for people to build it normally. But once you know it works, investors will come out of the woodwork. Or alternatively, if it fails, how many people spend how many man-hours thinking about this experiment? If we knew for a fact it was false, or worse, a hoax, we could finally just say, you know what? We're done with it. It's gone. Let's move on to something better, because the better ideas are out there in droves. Things did not quite work out the way we'd hoped, the funding, and we're still working on it. We went to Plan B and then C, and I think we're working on Plan F now. So it's a challenge, as pretty much every single one of you in the audience has realized. I guess the caveat to this, one of the real learning experiences for me has been, again, having become a little bit more establishment in the way that we approach things, nobody in the establishment has money for this stuff either. In fact, it's kind of scary when you think about it. Even NASA is not putting any money into this research. So I guess at the end of the day, what we really have to focus on is building a larger community infrastructure, educating the public, and really selling them on the vision for these technologies. Again, my focus tends to be gravity and space.
I corresponded with Mark Millis a few days ago, and he said that he's looking for some other channels to try to find the funding to integrate these propulsion things.
Yeah, Mark is a wonderful. He's an awesome person. I think the problem that he's encountered has been, I guess my official view on NASA's work has been they have launch schedules to meet. They have a lot of money that they have to put into their projects now, or else people who are up in space in today's world will have serious problems. So they allocate their resources to meeting their outlined schedules, putting satellites up and stuff like that.
Breakthrough propulsion physics in the States and now only costs about $500,000 to do the research compared to billions on other projects.
Oh yeah. Well, and I guess it outlines the other aspect of it, which is part of it is public perception of return. When I worked at AT&T, I worked on the fixed wireless project, which is now completely defunct. I won't go into too many details. AT&T was spending $1 billion a year on research and development, and they were happy with that. So for our entire community to have 1/100th of that would probably get us, a lot farther. Sorry.
Would you like to have some help with your anti-gravity work?
No.
These so-called UFOs are properly called shuttles, and they have to have a mothership. The mothership over North America that's assigned to North America is called the Capricorn. And the Capricorn has offered to send some of their engineers to help, though they're not going to take over, but you have to request them. So if we, for example, in our lab, we've asked 2 of them to come to help us in the development of our new energy stuff.
Yeah.
So I can give you the information, and you can contact the Helena, who is the commander of the Capricorn, and they'll
I've been
send
following,
1 or 2 people to you.
I appreciate you bringing it up. I've been following the story. This is Hal Fox, right? This has been making rounds on the internet, and I have not been sure what to make of this. I guess our focus with regard to UFOs, like everybody else on Earth, we're still asking the big questions. So our focus has been on the technology because it's less controversial.
Is it time for questions, or do you have more?
I think I'm just about wrapped up. I know that there are other presentations after me. I hope I haven't run over time.
You still have one more time.
Oh, okay. Well, yeah, absolutely.
Okay, I was concerned about one thing when you kept talking about Einstein's bell. So I'm familiar with Nick Cook's book, The Hunt for Zero Point, and in there he makes the case that it was the Nazis, the Germans, that designed and constructed the bell that had nothing to do with Einstein or his physics or the Lorentz transformation, which was not Einstein. So I didn't like that connection between Einstein and the bell.
Part of this comes out of, actually this is stuff, part of this comes from, I'll keep it really short. With the Nazi bell stuff, I hope I didn't say Einstein's bell. Einstein's unified field theory comes into this through John Daring, who helped us do a really large story. Igor Witkowski wrote a wonderful book. It's called Truth About the Wunderwaffe. It sells, if you can find it used. If you buy it new like I did, it takes about a month to ship here and costs about $80 American. So it is a little bit on the expensive side. It's an oversized book with small print and about 50 pages. I mean, it's an enormous section on the Nazi bell. Witkowski was able to probably put 2 or 3 times more detail, more data into this, as well as extensive photos of everything relating to the bell. I see you have the book right there, just for everyone else's benefit. But Truth About the Wunderwaffe details this in depth, and it's a wonderful book. John Daring came forward to help us write a story about the connection to Einstein's unified field theory, and there's actually further speculation that it may in fact not have been Einstein's theory, but Heim theory. The reason being, in World War II Germany, they really didn't like Einstein that much. So Burkhard Heim, who was working on a pretty similar theory, would have been a good shoo-in candidate that could have been proposed. Now, the person who proposed this project, the reason that I think John was so adamant about Einstein's UFT, part of it was, I think, their approach to designing it. The other part was the chief proponent of this project was Dr. Walther Gerlach. Walther Gerlach had helped Einstein vet the papers in the 1920s for the unified field theory. So, one of the criticisms would be they wouldn't even have this theory. He was with it in the US at the time. They actually had it through handwritten letters where Einstein would write to Gerlach and say, what do you think about this part? Now, it's possible that Gerlach could have pushed this through Heim theory and said, well, this is pretty close. Why don't we sell this to the Reich and then get it developed? I wish I had more evidence there. I actually have an acquaintance who has promised me photos. He went to Poland on a vacation and apparently used climbing equipment to very surreptitiously take photos of the entire area from the top of the bell tower. So hopefully I'll be able to put those up pretty soon. I think the bell is leading us somewhere. I'm not sure if it's the final place that we need to be for this research, but I think it's taking us further down that road. Are there any other questions? Oh, go ahead.
I'd like to comment on 4 things that you mentioned. You started with the lifter, and you know how it kind of hovers around and it's not stable? That's because you can't afford to put an inertial guidance system on it. But 2 things that would improve it, if you right down the center of it, I know it doesn't have anything in the center, but if you put a very thin 3-foot piece of balsa wood with a teeny weeny weight on the bottom, that would give the whole thing a significant rotational moment of inertia, and it would be far more stable. And then not only that, but on the bottom of that, near that weight, put a couple of fins, which would, the ion wind would act like a aerodynamic surface there and stabilize it.
Sure.
Otherwise, the wind is just erratic, and so those two factors would stabilize, and they wouldn't weigh very much at all.
Actually, well, to really quickly touch on stability, lifters, the major factor in lifter stability is the height of the device, the overall height versus the overall length, like on a per side length. So the small ones bounce around a lot, the large ones are stable. In the video, which I think you're alluding to the video, we actually had to pull on the tethers to get it to do that. When you put them up, they stay up until they short out, and I have run them for 8 hours. After 8 hours of continuous operation, we did this on Earth Day in 2001. We brought the thing down 8 hours later, cool to the touch, same as it went up 8 hours before. So.
But this 3-foot-long thing, you'd have to start it on some pedestals. So
sure.
And that'll be similar to gravity gradient stabilization of a satellite. The second thing you mentioned, the Searle device, and that it gets cold, and it's supposed to have a vacuum inside of it too, and it's a localized, maybe a magnetic field. Now you said if it was really anti-gravity, it'd take the bench up with it. Now it's my understanding that it does go up, but when it leaves the earth, it sucks up a lot of dirt with it, and that is strictly due to the vacuum. If there's a vacuum, it'll suck up anything that it can suck up.
The part of the story that I'm not supposed to tell you guys, at least from what John Thomas told me, was part of the ground plant. That's what they call it. When the SEG lifts off, there's something called a ground plant. It makes sense if you have a spherical field or on a disc-shaped device, part of that sphere is going to cut into the dirt, and it'll take that dirt up with it. Now, part of that supposedly was Searle had the idea from a dream and transposed the original design, like people transpose letters and numbers. In his case, it was the electrical field vectors. So he actually had the very first few of these built backwards. And when they took off, this caused apparently a number of issues, as well as the ground plant. When they switched the field, they literally reversed the gradient there. Apparently it worked much better, and they didn't have that issue anymore.
Okay, the third thing you mentioned, like anti-gravity is like a dirty word or something, and they come up with new names like inertial propulsion. Now that's one of my favorite topics, and in theory they say that you can't have motion without a reaction. Like the shuttle goes up, it spits out about 6 million pounds of fuel in the opposite direction. Now we know that you can have motion by mass displacement from Dr. Eric Lathwaite's type experiments, which he got from Alex Jones. But and in there you can move and there's no apparent reaction. Now I maintain, I'm studying this in great depth, I maintain that there is a reaction, and it's not one we can see, but it's in the ether. The ether is full of energy, and it doesn't mean that if you move 10 pounds this way, 10 pounds in the ether moves this way, but there's an equivalent, like E equals mc squared. There's some equivalent reaction in the ether which we don't perceive.
Well, you're talking, what you're touching on for the rest of the audience, you're touching on Mach's principle. Mach's principle is pretty complicated. In terms of research, actually, Lathwaite with gyroscopes was a good way to go. De Palma, one of Bruce De Palma's big, I guess, parts of that was, he thought that speed, the actual rotation speed, helped, so he wanted to rotate things using a nuclear magnetic resonance technique, where you rotate the atoms, because they spin a lot faster and there's a lot more of them. As a single atom basis, they have less thrust, but as a net thrust, you have more. The other part of Mach's principle, in terms of current research, Paul March and Jim Woodward, right, the Woodward effect, they've been using piezoelectric devices, and they are getting appreciable thrust, and that's really a first. Mach's principle is best known for off-center rotators. There are 100 different designs out there for these. They're usually really visible. People take them out to the fairs to show people. The problem with off-center rotators, I mean, the biggest problem is being mechanical devices, and because they throw mass around and then try and constrain it, they self-destruct more often than not. And so even if they do work, they usually only work for a few cycles.
Okay, my last comment was on, you mentioned the speed of light. Now, I'm a firm believer that the speed of an object is not limited to the speed of light. The perception right now is that we use light to measure the speed of anything, and that's the medium. So we can never measure anything to be going faster than the speed of light because it's the light that we're using it to measure with.
Oh, could
Now,
I actually, let me answer this indirectly in terms of the speed of light, because this, we work in an area with gravity research where there are a lot of theories. And the example that I love to use for this, if I remember right, is called a phonon. Now, a phonon is a particle of sound, okay? And this is actually, if I remember correctly, it was part of quantum mechanics. Now, everybody who's taken basic physics, probably high school chemistry, knows that sound is a scalar wave in the atmosphere. It's air molecules pushing on things. There is no sound particle. It's kinetic energy. And so the phonon is a mythical particle. The problem becomes, the reason that it's required is in quantum mechanics, you need a particle and a wave for everything there. And so the phonon was a result of the limitations of that model. So one of the things that we're trying to do with gravity research, again, because we're working with more and more mainstream types as time goes on, and because we're trying to work with a variety of different approaches, and we're trying to value everybody's approach, as it deserves to be valued, we're trying to work within the models that we have available. So within relativity theory, it's possible that you can violate the speed of light constraint, but we like to try and work within the model as it exists, and then publish extensions to that when necessary to say, as caveats. The speed of light limit exists in relativity, not necessarily in unified field theory. The torsion tensor doesn't exist in relativity, does exist in unified field theory, which is actually one of the big differences between, I guess I should wrap it up, but American and Russian research, they were very heavily into torsion field research, which we're starting to wonder now, if they inherited some stuff at the end of World War II that might have gotten them to go in that direction. They spent a lot of time in the 60s working on torsion fields. These are loosely related to Einstein's metric torsion tensor, and there are different variations and different authors who published on it. One of our questions is starting to become, what got them involved with that, since American science just blew right on by it, never paid 2 cents worth of attention for it. I'm sorry.
Okay, thank you.
Thanks.